Hello, data nerds and data enthusiasts. Welcome to another class. Today we'll continue from where we stopped the last class, and then we look at the Python crash course 2. I believe and I hope you enjoyed the last class, and you must have done a little bit of practice yourself to sharpen your skills, because that's the only way you will be able to keep in touch and find this class interesting as we go on. So today, in our last class, we looked at Python characteristics, basic data types and structures, string manipulation, string slicing and indexing, slicing of data structures and their methods. So for today, we'll be looking at the Python crash course 2, where we'll also perform some operations. So, but before we start, I wrote some things here. I said in your current environment, check if the following packages are installed. So we'll be basically looking at some Python libraries and to see if you have them on your computer already or you need to install or import them. So first of all, we'll start with pandas. So data analysis and manipulation library, especially for tables and data frames. So we use pandas. Pandas is a library in Python that we use for data manipulations and then for tables, creating data frame and all that. So first of all, you check if you have pandas library installed on your Python. Most times they will be there. They will be able to just check. So you know how to say. You say pip show pandas. Hmm? You run the code. So if you get a message like this, so which means you have pandas, say name pandas version 2.3.1. It just gives you a summary uh about the package, about the library on your system. But if you don't have it, you can simply what you can simply do is just say pip install pandas, and then you run the code. You see, it says requirement already satisfied, which means I already have it. That's for pandas. Then if for numpy, the same thing, you say pip show numpy. So we run the code. So show you, give you the summary and all that. The same thing as well. If you don't have it, you say pip install numpy and run the code. And then it shows you requirement already satisfied. That means I already have it. So that's the same thing for Seaborn. Seaborn is just like a Python library we use for visualization, just like maybe you want to plot graphs and the likes, just like using professional dashboarding tools like BI, Tableau, and even in your Excel, you do that. So that's what you use Seaborn to do as well. Plotly is a dashboarding library as well. But Plotly, the difference between Plotly and Seaborn is that Plotly is more interactive, where you can interact with the your diagrams and all that, and then you can click and then see some sections of the data as well. But scikit-learn, we might not be looking much about scikit-learn because it's basically for machine learning. It's a machine learning library for building models and the likes. So we'll be concentrating on pandas, numpy, probably one of these two, either Seaborn or Plotly. Okay, so I will not be needing this, so I will delete. Okay, so today we've looked at the libraries we want to talk about. We'll start with the pandas, and after pandas, we looked at NumPy, and then maybe if we still have a lot of time, we'll look at the other one as well. So then I have an exercise here that says you have two Python lists, that is the city list and the population list. So the city list has a variable name called city list, and then we have various cities: Tokyo, Delhi, Hong Kong, Sao Paulo, Abuja, and then the population list for these cities is this 37.4, like that. So it said step one that we should make a dictionary from the city list and the population list. And then the second question says make a third list country index, which is given already. And then the fourth one, make a data frame using the dictionary we created as data and country index as its index. You don't have to worry about this. It might sound a little bit confusing, but then as we are about doing it now, you find it that it is not something really, really special that you should worry about. So now let's see how we'll go about it. So now, what this whole exercise is talking about is just simply asking us to create a data frame. And now it's asking us to create a data frame using this cities that has been given with the corresponding population. So he's saying create a data frame such that one of the column will have the name city, and the other column will have name population, and then align the population to these cities, and then we should create an index using the name of these countries that has these cities. So okay, let's just copy this out. This is the city. I copy this out. Okay. Okay, so this is the variable name, and also let me copy the country index out as well. Okay, so let me run this tree, run them. So for instance, let's call the first variable, which is the city list, and see. So if we call the city list, so it gives us Tokyo, Delhi, Hong Kong, Sao Paulo, and Abuja. So it's simply asking us create a data frame like a table format such that one column will say, okay, city, then you have Tokyo, Delhi, Hong Kong, Sao Paulo, Abuja, and then you have another column population. You have 34.4, 28.5, 25.5, and then you have the index column will now represent the country. That is what this is all about. So how do we do? We'll first of all create the dictionary, just like the question says. Say we should make a dictionary. Remember the last time, remember the last class we talked about dictionary, and we said the dictionary makes use of what? Coily bracket. So it's asking us to simply convert this list into a dictionary and then create a data frame. So let's name it dictionary as a variable name, and then put the coily bracket, and then the column, I want the column to be a city. Remember, I talked about in the last class when we were talking about data structures. I said dictionary are key pair values. Like you have the keys and you have the value, they are paired together. So we have city. So what do we want to represent the city? We want this city list, this variable now, to represent the city. So I want the column name to be city. But under that column name, the cities I want to be there are these cities on this list here now. So this is the key now. So the value I want to be on this key will have this variable name city list. So I put here city list. Now the next column I'll put a comma. Now the next column I want the name of the next column to be population. I think I'll use small letters because it is easier to remember because they are case sensitive. So I'll use population for my next column, and then on the population, what do I want? What figure, what value do I want? I want this population list that is displayed on this list to be there. So I use the variable name here, pop list, right? Now, if you notice, you will see that I did not use the quotation mark in on variable names. Why? Because they are variable names. There's no need. But you see the new strings I introduced, the city and the population, I use the quotation mark because they are strings. If not, the code will give us an error, right? So I've run this code now. So let's call this dictionary dict now and see the value, what it will give us. Okay, so we've successfully created a dictionary. Now it's showing us city, Tokyo, 37.4, Delhi 28.5, Hong Kong 26, Sao Paulo. But this is not what we are actually looking for. We have successfully created the dictionary. But now, how do we create the data frame? Now, the question says we should create the data frame using an index. We should use an index, which is this. We should use an index, which is this, which is the country names where these cities are located. So we use a function called to data frame, or the PD data frame, which is the pandas function. So what do we name this now? We can simply just call it let's say um country. Let me name it country. Let me call the variable name country, right? Or let me just say CTRY. I don't know which will be easier. Okay, let's just call it country. equals to. So we use the function, we said pd dot data frame, pd dot data frame, and then we use the round bracket, and then remember it is a dictionary we want to convert into a what, a data frame. We are converting the dictionary into the data frame. So on that note, now the next thing we will do, so next, after giving the variable name country, or you can simply use the most commonly, let's just use the most commonly used data frame name, we'll call it df. So we said pd dot data frame. So what are we converting into a data frame? This dictionary here, which we name dict, we'll say dict, right? And then a comma. And then because the question says we should use the index, which is the country name, and this is the country index, the country names. So we indicate, we said we want the index to be equals to what is the variable name of the country index. So we simply put country index here. So if we run this code, oh, we're having an error. It said name PD is not defined. That's simply because we did not import pandas, despite when we were checking to see if pandas was already in the library was already installed. We did not import. So what you simply do is say import pandas as PD. If you see here, I put PD. This is just the short form of what, pandas. So instead of continuously typing pandas, you just put PD, and then the library will execute whatever you want to. So I've run that code now. So let me run this code now. Let me run the code. So everything will no error. So let's call the PD, let's call the df the data frame and see. So you see, we've successfully created a data frame. The index here now is the countries: Japan, India, Hong Kong, Brazil, Nigeria, and you see the corresponding cities. Tokyo is a city in Japan, Delhi is a city in India, Hong Kong is a city in Hong Kong, Sao Paulo is a city in Brazil, Abuja is a city in Nigeria, and you see their corresponding population. It's as easy as that. So you can perform simple operations like, for instance, let's say you want to check the top five, the first two countries alone. You can do something like, let's say df dot head and put two, and then you run the code. It will show you just two cities. You can say three. You just want to see the first three countries. It should show you the three. If you want to see maybe the last two countries, you put df dot tail. You know, it will give you the last three countries, Nigeria. So like that. So that's for that. Let's move down to data importation. Data importation is just simply you've been given a data, and then you are asked to perform some operations in the data. Maybe the data is in CSV format or Excel format or Pico. You want to bring them into it could be even HTML data and all that. You want to import it into pandas, into Python, so you can perform some operations and then maybe carry out data analysis process through those data. So that's what we want to check out today. How do we import data into Python? Maybe an Excel file or a CSV file. It's quite simple and easy to do. So the first thing you need to know is, for instance, you need to know where the data is being saved on your computer. So for instance, I show you, this is my computer. I have a folder on my desktop that I named lecture vids. So I have some document here, and if you're on the Telegram channel, you see where I already posted the data we'll be using for today. So you see the Titanic, the CSV, the superhero. So these are the data we want to use. So the first data we'll be importing is the titanic.csv. There are different ways you can import data into Python. The first one is simply looking at this data now, titanic.csv. If I right click on it, and then if you're on Mac, you press the option button. Then if you press the option button, you see something like copy titanic.csv as path name. You click on it. Now, when you click on it, you go back to Python. Now, I'll create a path. I'll say path, a variable name path, and then I'll place in an inverted comma, I'll place that part I copied. I place it here. I name it as part. Now I want to import this particular data, titanic.csv. So let me name the data frame name as df2 equals to. So we use the Python function in the list in the Python library. We call it we'll say pd dot, okay, we'll say pd dot read underscore csv in a bracket. Now, this is the part where this particular data I want to make use of is saved. That's it's if you check on my computer, users, and then inside users, user, then on my desktop, then on a folder called lecture videos, there's a what? There's a file there. But now the part I want to create, now, for instance, is not actually supposed to include this. So let me just remove this first. So this is the part, this particular file I want to import is located. It's located inside this lecture videos, and this is the part, this is where these are the places you enter before you find that data. So I just created a part now. Okay, I ran the code. So now I'll come here. I said, okay, this is data frame name df2. I use this Python library function pd.read underscore csv. I'm stating that I want to read a csv file. So I will have to write a code to tell the machine where is this file located. I'll say it is located in path times. I'll tell you that if you go to these places on my computer, you will see it. Then after you enter that place, plus, you will see a file called titanic.csv. So the computer will first go through this part. You say, okay, part, and then the computer will go enter here, enter this place, enter your desktop, and look for a folder called lecture videos, and then look for a name called Titanic PSV. Then it will be able to read it. So if I run this code, I successfully ran this code. So now let's call this variable name df2 and see if the file has been imported. So let me run the code now. I run the code. So you see, I've successfully imported the Titanic CSV file into Python. So I can perform various operations here now. Having imported this data, I can perform various operations. Now, this is the first way. I mostly use this way most times because sometimes I work with multiple data and all that. So instead of continue copying the path and all that, and then I'll just have to say, okay, I know the name of the path. I already know that they are all saved in one folder. So all I have to do is just put the path and then put the file name I want to import. So another way you can do that is by simply just going to the data itself and copying the path. If you copy the path and then you just say, let me call it df3 pd dot read underscore csv, and then all you simply do, you paste the path here. So if you still run this code, it will still give you the same thing. So whichever one you think it's easier, so you can see you still have the same thing. So it's either you create a path and all that. Now the third one is very simple and straightforward. This third one is that this particular notebook I'm working with, this particular Python notebook I'm working with, if I save it in a particular folder, all I have to do is just pick the data I want to use and go and save it in the same location where I save this notebook. The same location where I save this notebook. So if I put it in the same location where I save this notebook, all I have to do is just to come here and say, let's say for instance, df2 equals to pd dot read underscore csv. Then I just put my quotation mark and type the name titanic dot csv. So if I run this code, I'll still get the same results. So if I call df2 and run the code, you see. So you might say this one is a little bit shorter, but it will not work if the notebook you are currently working in is not saved in the same direction, in the same folder where the data you want to import is. So, but if the data is saved in the same location where the current notebook you are working with is saved, then you have it like this. It is easier. So you can use any of these three ways to import data into Python, and then for various operations. So let's look at some operations I've been able to outline here: the columns, the index, the d types, the n unique, is null, and all that. Okay, so we've done this. So I'll have to delete this. So we'll just make use of the first one. Okay, now first of all, let's look at the columns. Looking at the columns is simply just getting to know the columns in the. Okay, let's start with the column. Okay, yeah, the columns or the D types rather. Let's look at the D types. For instance, the D types is just simply knowing the different type of data types each of the columns are in the data. So we call the data frame as what, df2. We call it as df2. That's the data frame type. Say df2. No, sorry, columns rather. Df2 dot what, dot columns. So if you run this code, so it will give you the various, it will show you the various columns. Maybe the columns are like 40, 50. You want to see how many columns, you want to see the columns that are on the data, probably because you know this is very, very short and this is very, very small. So you can easily see them because there are just how many columns here? 1, 2, 3, 4, 5, 6. Sometimes you can have columns up to 50. You cannot see all of them together at the same time. So what you simply do, you can use the columns function to see the all the columns in the data. If there are 100, you see all of them all listed here. You get to see them, and then you wouldn't have to maybe scroll and all that. So maybe you want to check if there's a particular column of concern that you need to check, so you can easily just scroll through and then you get to see the column you are looking for. So for the next one is the index. Okay, the index is just getting to see the index number. This is the index number. This is the index number of, and it is automatically generated by Python, showing 0, 1, 2, 3, 4, 5. Remember when we were doing slicing, I told you about indexing, that the first index is 0 to 1, and it's like that. So let's look at the index. You just simply call the data frame name df2, which we name df2 dot index, and then if you run the code, it shows you that the range of the index starts from 0 and stops at 418. What it simply means that this data altogether has 418 rows and what, 6 columns. So it's saying that the index starts from 0, stop at 418 with a step of 1. A step of 1 simply means the difference between the preceding and the succeeding row is just 1. So we have 0, 1, 2, 3. So the difference is just between them is just 1. So if the step is telling you that it is 2, it simply means that the difference between the preceding index and the succeeding one is 2. For instance, maybe the first index will be 0, the next one will be 2, the next one will be 4, the next one will be 6. So that's index. You can use it to check the dimension of the data and how the index are being arranged. So you see it here. So the next one is the n unique. The n unique is used to get the number of unique values within the data. For instance, let's say we want to see the number of unique values in this data. We say n unique. So if we run the code, I run the code now. You see the data frame name df2.nUnique is a function. It will show you that the passenger ID column has 418 unique values, while the passenger class has about 3 unique values. The name has about 418 unique names, which means no repetition of name. All the names in the names column are all different names. No two people are answering the same names. Sex, you have just 2 unique values. Of course, we know that's male and female. While on the age, we have 79, and then on the fair, we have 169. Also, you can decide to say, okay, you want to check the new unique values in a particular column. Maybe you want to check the new unique value in just the sex column, and see, you can just simply say df2 and use the square bracket and particularly call the column you want to check. So we want to look at the sex column. So say dot n unique. You write your code and then you run the code. It show you what, 2, that you have 2 unique values in the sex column. Just 2 unique, of course, and we know that should be what, male and female. I think you know that that's already male and female rather. You know that the only unique sex we have is definitely male and female. I don't know about the other one. If you know, maybe you can tell me. So now that's for unique. if we look at is null, what is null used? Is null is used to check null values in the data to know if there's a particular column that has null values. Like for instance, let's look at um, df2, that's the data frame name. Let's look at the age column, put our inverted comma. Let's look at the age column to see if there's null values. Say it's null, and then we run the code. So it's showing false, 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 true, false. For index 0, it says false. For index 1, it says false, which means it simply means that for index 0, it is false. There's no null value. There's a value there. Anyone that shows true, it means there's no value. So for us to look, let's say dot sum, we'll add another function and sum it up. So it's showing us there are about 86 null values. There are about 86 null values in the age column. That's what it's saying. So now if I use another function called the value count can calculate the total number of null values, which says on the age column false is 380, 332, while true is 86, which means there are about 86 null values in the age column. So these particular functions and we've been looking helps us to know about the data we are working on, and it gives you the clue of what you want to work for, what you want to work on. So we look at the next one, which is the sum, which I've shown you now, and also the value count. The value count, for instance, let's say we on the sex column again. Let's call the data frame name df2 age. Okay, let's look at the age. I will say the age dot value counts. So if we run this code, so it will show you the number of values for each of the age that are present in the columns. So for instance, it's showing that 17 people are 21 years of age, 17 people are 24 years, 16 people are 22 years, 15 people are what, 30 years, like that. So it's showing you all the length of about 79 and all that on the age columns that has the same uh, values in terms of age for this particular. The same thing you can use it for the for the for the other columns like the sex columns and the likes. So that's how these little features work: the columns, the index, the d types, the n unique, the is null, the sum, the value count. And then the last one, you have to go and check how to do it. But what duplicate simply means is helps you to check if there are duplicates in a particular column to see if there is a repetition of same data in the same column. Sometimes it can be correct, but it has to be in a column you are not expecting. It is only useful for a column you are not expecting for there to be duplicate. It will not be useful, for instance, in the age column, because of course 2 or 3 or 4 individuals can be of the same age. But then some other times when you're working with data, there are some columns you don't expect duplicates, so you can use it to check if there are duplicates in the particular column. That's how the duplicate function works. So now let's look at some other operations. Remember we did slicing. So let's take, for instance, we want to check we want to see just the column, we want to see the data in from the index number 7 to 90. So we just want to see the number. So if I click here now, if I run the code, you see to show me just the data from index 7 to index what, 90. That's how it works. Remember we said the last is not is excluded while the beginning is included. So that's why you see that it ends at 89 if you followed our last class when we talked about indexing and slicing. So I just want to view, you can specify the number of data you want to, the amount of data you want to see or work with at a point in time. So I just wrote a short code that I just want to see from index 70 to index 90, or probably I just want to see the first 5. If I use this function called head and I run the code, it will show me just the first 5 data from index 70 to index 90. If I want to specify, maybe I say I want to see the first 15, I can specify here, and then I run the code to show me the first 15. If I want to see the last 5, within index 7 to index 20. I'll just change this. I change it to, instead of head, I put tail, and then I run the code. It will give me the last 15. If I just want to see the last 3, I change it to 3. I run this code. It will show me the last what? The last 3 data. That's for the use of the head and the tail and slicing as well. We can also do slicing by simply, for instance, maybe I want to look at I want to look at I want to look at names of individuals who are females alone. I can call and say df and then specify that that I want to see individuals that are female. So from here I'll say sex equals to female. So if I run this code and then I call df, oh sorry, df2, not df1. So this should be df2. This should be df2. So if we run this code, call df2, so you see, it will give us just females. It will give us just the individuals whose sex is what? Is female. So how about if I want to get the individuals whose age is greater than 24? I just want to view individuals whose age is greater than 24. Okay. Let's say, sorry, individuals whose age are greater than 24. Let me just run the code here. So if I want to get individuals whose age are greater than 24, I'll say df2. I call the column, which is the age column. You have to be careful about the case. It's if you if the columns has capital letters and you call small letter, it will return an error. If it's small letter and you use capital letter, it will return an error. That is why it is most times advisable to use small letter in naming. So because they are mostly easier to remember and all that, to avoid too many bugs and all that. So I want to check the individuals whose age are greater than 24. So I say the data frame or the column age whose age are greater than 24. So if I run this code, you see it's showing me column 1 is true, column 0 is true, column 1 is true, which means column 0 is greater than 24, column 2 is greater than 24, column 3 is greater than 24. The one that shows false is simply telling you that this particular individual on this column, his age is not greater than 24. That's what it implies, that the age of that individual on that column is not greater than 24. Okay, now see, if we run this now, you see, okay, I already did for female. If we run this, if you see this particular column now, you see you just have individuals that all their ages are greater than what? 24. You see 34, 47, 62, 27, 30, 50, 37, all are greater than 34. You can also combine two functions and say you want an individuals who are male and their age greater than what? 34. You can also do that as well. So you see, these are all the individuals who are male and their age are greater than 24. So let's assume you want to make two expressions such that we want to see only individuals who are males and their age are greater than 25. So we can also do that, two expressions. So the first one, we check for the data frame name. We want to look at individuals who are male, right? The individuals or who age are greater than 25. Let's start with age. We say age. We want those who age is greater than what? 25. That's the first one. The second one, we want individuals who are what? Who are males. So under sex, whose sex equals to what? Who are males. So now we have to combine these two and these two together to get what we are looking for. So how do we combine them? We use the AND. So we first of all wrap each of them as separate expression. This is the first expression with the round bracket. So we'll wrap them, and then I just move this one here. I wrap this one as well to show they are separate expressions. And then what do? I put and here. And so it's just simply saying we want individuals whose age are greater than 25 and also whose sex are equals to what? Male. And then we include the data frame name, round the both expressions using the word the square bracket. So if we run this code now, it will give us individuals whose age are greater than 25 and who are also male. So let's run the code. Oh, okay. It said cannot assign to subscript here. Maybe you may. Oh, you see, I made an error. Remember when we were talking about assignment? I told you I made mention of saying equals to is an assignment statement, and then we said this is an equality statement. So it simply means I used equal to, which is an assignment statement. I'm assigning this to this column. So that's why it's giving an error. So, but if I use this now, it should be fine. The code should be fine. So let's run the code. That's cool. So you see now, we will only get the data where the individuals are males and their age are greater than 25. If you see now, you have index 0. Index 1 is not there because index 1 should probably be a female or maybe a male whose age is less than 25. You see index 4 is not here. Index 5 is not here. Index 6 is not here. So they are either females or probably they are males whose age are what? Less than 25. If you check all this, you see. So let's look at, okay, let me say dot head. So we see the first 20. I run the code again. So you see, they are all males. You will not see any female here, and you will not see any age that is less than what? Than 25. So if we swap this for male and change it to female and run the code, you see, it will give us for female as well. And then from the name you see Mrs. Edwin Nelson, Racing, Mrs. Otto, and the likes, and you see the age as well. So that's how it works as well. You can also decide to say, okay, you want to see those whose fare are greater. You just set your benchmark and then write the code accordingly. And so you do that. There's so many functions. So this is just basically introducing you to just the simplest functions. You can perform functions like mean, median, average. For instance, you can say you want to check sum up the age of all the individuals there. You just say df2, then call the column particularly of which you want to sum, say age dot sum. Then if you run the code, it will give you the sum of all their ages, which is 1050. So if you want to get the average age, you already know that the total columns for this particular data set is 418. So if you divide by 418 and run the code, it gives you the average age. The average age in this case is what? 24. So these are just the basic things we need to know about importing data into Python and how we can perform basic operations, and then we can also assign statements as well. So you can also decide to create a column, an additional column in the data frame by just using the assignment statement. For instance, if you say df2 and then you give it, let's say, height, and then say equals to 56, and then you run this code. If you run this code and then call the df2 again, run the code, you see a new column will be what? Will be added, height. So I just successfully added a column, a new column, height, but then I used a single value for all the individuals. So but it's just an example I'm giving you. It's just an example for you to know. You can add a new column and also remove as well. So this is just basically, you see, this is an assignment statement as well. You can also change values within columns here as well. So you see, when we're talking about is null, you see, this is example NaN that showed us that we have about 86 null values. So these are the basic operations you need to check in the data. Check for duplicates, check for null values, check for special columns, check for other things for you to understand the data pattern first before you start carrying out analysis. But this is basically introduction. In our next class, we'll go deeper, we import more data, we combine data and merge data as well. Please do well to follow me on YouTube, and also subscribe and help share this video for a wider reach so that we'll get to impact others, and also others can also benefit from this class. It is completely free of charge, and the only thing I expect from you is just to share, like, and also invite your friends to become part of the community. Thank you, and see you in the next class.